Assalamualaikum. My name is Muhammad Nasri bin Shawal. Today I want to present my PSM project. The title of my PSM project is the study of comparison mechanical behavior on aluminium alloy 6061 using friction steel welding in dry and underwater condition. Introduction. Friction steel welding is a solid steel welding process for joining aluminum alloy C061. Friction steel welding appears today as a promising ecology method of welding that allows material waste to be minimized and the radiation and harmful gas emission from normally associated with the process of fusion welding to be avoided. In precision welding, the current was aimed to study the mechanical properties such as a tensile test to know the material properties after welding when using dry and underwater friction steel welding. In this project, dry and underwater friction steel welding joint were made using different level of process parameter and teeth angle during joining the aluminum alloy. The tensile analysis was carrying out to identify the optimal welding condition to attain maximum strength for each alloy. This relationship can be effectively used to know the tensile strength of material according to the friction steel welding process based on the selected parameter. Problem statement. Different parameters of friction steel welding given the different quality of the welding product. Besides, the condition of friction steel welding also given the different quality of the product during the welding process. There are two conditions of friction welding process that are dry friction steel welding and underwater friction steel welding. The same parameter and different condition of this friction steel welding are given a different quality and tensile strength of the welding product. Second, there are several weld ability of joining that can be produced during the welding process, which is the best quality of joining weld ability after welding process, such as tensile strength of the material. Third, different condition of friction welding makes a different result on the mechanical properties of the material. The tensile strength of the material after friction steel welding is important because the higher tensile strength will give the best quality of the friction steel welding process. Okay, this is a objective for my PCM project. First, to study the best welding parameter using the L9 Taguchi method concept for dry and underwater of friction steel welding. Second, to study the weld ability of aluminum alloy 6061. Third, to study the tensile strength of dry and underwater friction steel welding by using the different parameter. Scope for my PSM project. The following are only a few important elements that must be followed to ensure that all project objectives are achieved. This project includes the create, adjust, and tool of friction steel welding, which weld ability different parameter process of friction steel welding, and analysis of tensile. This research is carried out using the conventional lathe machine, conventional milling machine, conventional grinding machine, CNC milling machine, and wire cut machine, which is available in the manufacturing technology laboratory. The material selected for tool, jigs, and workpiece of the friction steel welding based on the genre study. Use the conventional milling machine to test the friction steel welding process for welding the aluminum alloy as the jigs that produce with the different parameters that follow the design of the experiment DOE. After that, do the tensile test to see the tensile strength of friction steel welding and select the best result of the tensile strength using two types of friction steel welding with different parameters. Okay, this is a literature review that I researched before do the PSM project. This is a flow diagram for my PSM project. Okay, firstly, start, then go to the general review, then design tool and jigs. After that, fabricate tool and jigs. Then running the friction steel welding with dry condition. after finish running friction steel welding with dry condition, running the friction steel welding with underwater condition. Okay, then cutting the workpiece which follow the ASTM ES dimension. After that, go to the tensile testing, then study the data, and lastly, end of the project. This is a Gantt chart for my PSM project. Experimental setup for run the friction steel welding process. Firstly, we fabricate tool of friction steel welding process. To fabricate the friction steel welding process tool, firstly we design the tool using SolidWorks software. The design of the tool is based on the general study and also based on the equipment available in the laboratory. Next, use a lathe machine to cut the tool of friction steel welding process, which use turning process based on follow the design of tool dimension. Okay, after that, use the sensor milling machine to cut the taper angle of the tip of tool for friction steel welding process. Then we can get the tool of friction steel welding process. Second, to run the friction steel welding process, we fabricate jigs of friction steel welding process. First, to fabricate the jigs, design the jigs using the SolidWorks process. Then go to the grinding machine and grind the surface of the jigs. After that, use high gauge to make the marking process. Then go to the conventional milling machine to drill the hole. Then to make a trick, use a taper process. After that, assembly jig with the toggle clamp and run the dry friction steel welding process. After finish run the dry friction steel welding process, modify the jigs for underwater friction steel welding process, which assembly acrylic adds the jigs. Friction steel welding process. Okay, for running the friction steel welding process, firstly, we select the parameter and use the L9 Taguchi method concept for run the friction steel welding process. Then, setting this end tool as the conventional milling machine. Then, running the friction steel welding process based on the parameter that has been selected. Okay, after finish running dry and underwater friction steel welding, go to the wire cut machine and running the wire cut machine to cut the workpiece. Follow the ASTM EX. Okay, after finish wire cut process, go to the tensile machine for do the tensile test to check the tensile strength of the workpiece. And after that, collect the data for the dry and underwater friction steel welding process. Results and discussion from the tensile test experiment. Uh, this is a dry friction steel welding result. The highest of the average tensile strength of 155.946 MPa was observed from a sample from number of experiment 4, which is the tensile strength of sample 1 is 153.616 MPa and sample 2 is 158.276 MPa at the spinning speed of 750 MPa, feed rate at 15 mm per minute, and this angle about 1 degree. Okay, and then the number of experiment 5 is the lowest of the average tensile strength of 89.7766 MPa, which the tensile strength of sample 1 is 106.611 MPa. Sample 2 is 72.940 MPa at the spinning speed 750 MPa, the speed rate about 20 mm per minute and about 2 degree of this angle. This is underwater friction steel welding result. From the table, The highest of the average tensile strength of 146.376 MPa was observed from a sample from number of experiment 7, which is the tensile strength of sample 1 is 135.240 MPa and sample 2 is 157.512 MPa at the speed of 910 MPa feed rate at 15 mm per minute and this angle about 2 degree. And then the lower of the average tensile strength of 35.7247 MPa was observed at the speed 750 MPa. The speed rate of about 25 mm per minute and about 0 degree of this angle, which the tensile strength of sample 1 is 27.4523 MPa and sample 2 is 43.9970 MPa. This is a comparison of dry and underwater friction stir welding process. The parameter that is stayed in the dry friction stir welding more suitable as compared to the parameter of underwater friction stir welding. The conventional milling machine feed rate in dry friction stir welding is running with smoother movement compared to the underwater friction stir welding. The material in the dry friction stir welding is made and joined with the best condition and good surface because dry friction stir welding accept the good heat during friction stir welding compared to underwater friction stir welding. Through the underwater friction stir welding, the heat is moved to the water also and cause the problem to the process of melt and joining of the material and give an effect such as low of tensile strength compared to the dry friction stir welding. During the underwater friction stir welding process, the conventional milling machine had a problem which is sometimes the movement of the feed rate are not consistent compared to dry friction stir welding process more consistent. The underwater friction stir welding tool that used in the friction stir welding process are weighed due to the many time used, which is first start with the dry friction stir welding and then underwater friction stir welding process. Conclusion: the selected parameters using the L9 method concept are the main factor of the product result of friction stir welding. The suitable parameter in the friction stir welding condition produce the best result and the good quality of friction stir welding. Weldability of joining can be produced during the welding process, which is the best quality of joining weldability of welding process such as tensile strength of the material. The different parameter give the different result of tensile strength. The suitable parameter during the friction stir welding process produce the good quality of friction stir welding and give highest of tensile strength. Recommendation: select the parameter which use optimize the Taguchi method parameter in produce much better of the friction stir welding result on the plate. Tensile strength will be highest and the quality of the product produced are good in their performance. Second, use more tool in friction stir welding process to avoid tool wear during the process that cause the best result of welding. It is because the best results that make the metal material cannot be joining and the best condition of the welding part. Using the fixing jigs to make the joining of the workpiece is good and strong quality of tensile strength. And then, lastly, use machine that can support feed rate movement constantly to avoid jerking during the friction stir welding process. Okay, that's all. Thank you.